Creating a real singleton class in Delphi. The article describes how to create a class that follows the singleton pattern. The class described will take care of the singleton requirements and effects itself, effectively leaving the programmer to use the class as any others. A singleton is a class that supports the creation of just one object. It's like your computer, there's just one keyboard. So if you were writing Delphi code that simulated your computer, you would want just one object instance to deal with keyboard read, write, and control activities. Articles about singleton classes are rare, but there are a few on the internet. I've seen some in magazines too. But none of these articles include sample code to create a real singleton class. By real I mean that the class itself enforces the one instance requirement, instead of leaving that task to the programmer. All of the articles I have seen so far have required the programmer to use the class in a special way to enforce the singleton pattern. In this article you will see how to create a proper singleton class that includes logic to enforce the one instance rule. Note, the conventional approach, in which the one instance rule is maintained explicitly by the programmer, is not without merit. Real singleton classes like the one I present here effectively hide the details and awareness of the singleton pattern from the programmer. The programmer is relieved of the task of enforcing the pattern. That's good, but the programmer may also be unaware of the special nature of the class, which is bad. If you don't know that the class is a singleton class, then all sorts of errors can crop up. You have been warned. Writing the code. Our goal is to write a class that can be used like this: procedure test, var s1, s2, singleton, begin s1 equals singleton.create, s2 equals singleton.create, / do something with s1 and s2 here, s2.free, s1.free, and, I've left out the try, finally blocks and other safeguards for simplicity's sake. The goal is to make the singleton class behave in such a way that both S1 and S2 refer to the same object. Here's what we have to do: instantiate the object the first time create is called. When S1 is created above, ensure that when another create is executed, S2 above, the existing object is reused instead of another one created. Avoid destroying the object when it's not the last reference that is destroyed. When S2 is freed, destroy the instance when the last reference is destroyed. When S1 is freed above, is there a way to override the creation and destruction of a new object in Delphi? There sure is. In the TObject class, the mother of all objects, pun intended, There are two methods we can use: class function new instance, tObject, virtual, procedure free instance, virtual. New instance is responsible for allocating memory to hold a new instance of the class, and free instance is responsible for freeing that memory when the class is through with it. These methods control what happens when the object is created and when the object is destroyed. If we overwrite this code, we can alter the default behavior to work the say a Singleton class requires. Nothing to it. Tracking instances is a little trickier. We must keep track of each existing instance of our class, keep track of how many references there are to this instance, create a new object only when no instance exists, destroy the object when the last reference is removed. To keep track of an existing instance, we will use a global variable. Actually, the variable will ultimately be declared inside the implementation part of a unit, so it won't be a true global variable. But the scope must be sufficient to track all the create and free calls. We'll call the variable instance so we know what it refers to. As for keeping track of how many references exist, we need another variable. We can it inside the class or make it a sort of global-like instance. I'll opt for the latter way, but do what you feel is best. I'll name this variable ref_count. We now have two variables: var instance, Singleton equals nil, ref_count, integer equals 0. I initialize the variables so that initially they don't contain any garbage. I know that the compiler does this automatically, so this is just a readability issue. We'll need to declare the Singleton class above the variable block, and if you take a look at the example files that you can download at the end of this article, you'll see that I put the declaration in the interface part of the unit so that it's visible outside of it. Here's the declaration of the Singleton class. Type Singleton equals class public class function new instance, tObject, override, procedure free instance, override, class function refCount, integer, and I added the refCount function so that we can see that it actually works, and it's often handy to be able to read how many references to the object exist. It's not required, however, so you don't have to add it to your Singleton classes if you don't need it. Okay. Now for the implementation of the three methods: procedure Singleton.free instance, begin dec, ref_count, if ref_count equals 0, then begin instance equals nil, / destroy private variables here inherited free instance, and class function Singleton.new instance, tObject, begin if, not assigned, instance, then begin instance equals inherited new instance, / initialize private variables here, like this, / Singleton, result, dot variable equals value, and, result equals instance inc, ref underscore count. And, class function Singleton.ref count, integer, begin result equals ref underscore count, and that's it. When you call Singleton's constructor, a call is placed to the new instance method declared in TObject. This method allocates memory to hold the new object and returns it to the constructor. The constructor uses that memory and eventually returns a pointer to the memory to the code that called the constructor. This pointer is usually stored in a variable while the object is in use. I have overwritten the new instance method so it will allocate the memory only if no instance of the class exists. If there is an existing instance, the function simply returns that instance to the constructor so it will be reused. If we call the constructor 3 times, an object is created only the first time. The other 2 calls simply reuse the first object. The reference count variable let us know that we have 3 references to the single instance. When the program calls the destructor, a call to free instance is placed to free the memory allocated in the constructor. This method, too, is overwritten so that the object is destroyed only when the last reference is removed. If you intend to use a singleton in a multi-threaded program, treat the object as you would any variable you share between threads. Because that's just what you do, share it between the threads. So you must take special care when changing data. Simplicity itself, as you can see, creating a singleton class doesn't require much effort, just the right knowledge and a few lines of code. My code works fine in Delphi 5. The technique will probably work fine with older versions of Delphi, but I haven't tested it so I don't make any guarantees. Before I give you the file to play with, let me give you a few words of warning. Don't descend from a singleton class. The reason for that is that there is only one instance and reference count variable. If you derive 2 classes from Singleton, only one object will be created. The other class will reuse that object, which will be an instance of a different class. Don't go down that road. You can't make singleton components for the simple reason of ownership. A component is owned by a form and one component can't be owned by several other components. Remember that the constructor and destructor get called for each new reference as they are created and destroyed. Don't initialize private variables in the constructor and don't free them in the destructor. Instead, build that code into the new instance and the free instance methods, as shown in the comments. The order of adjusting ref_count in the two methods in conjunction with the rest of the code in those two methods is critical. It has to do with proper creation and destruction when something goes wrong. If your initialization code raises an exception, the order of doing things like shown above will make sure that the class is destroyed properly. Alter this code at your peril. The file that you can download is just a copy of the unit that declares the Singleton class described in this article. Link to file, Code Central entry 15083. I'm sure you can find a few places where a Singleton class comes in handy, and now you have the tools to create your own. If you want to get in touch with me, my email is lasse@sintra.no. Happy programming.